Oh, sorry, you caught me drinking my delicious Brugger's coffee. Oh gosh, Brugger's still not making any money. I'm still using this really old laptop. I really like a desktop so that I actually can record and do some things at the same time, but I can't afford one, man. Just kidding, kids. Here we go. I'm not kidding. It's a crappy computer. If I showed it to you, you'd be like, oh my God, I can't believe that guy's using that computer. At any rate, let's get started. Let's get ready to rumble. We are on Unit 3, finally. Oh my God, I'm so excited to be here. Mr. Key is back. There he is, ready to rock and roll. Rockin' a roller, rollin' rocker. Yeah, Unit 3. All right, about a 10-day unit. About a 10-day unit. Finish this right before Thanksgiving. Turkey. Oh, I'm already falling asleep just thinking about it. It's going to be awesome. Let's talk about graphing quadratic relations and functions. Oh my God. It's like 5 o'clock on a Sunday morning and I can't even be more excited to be doing this. I know you got to be excited to be here. All right, we're going to learn a new parent function. Learn a new parent function. No, you're not going to learn it. You already know this parent function. It's the parabola. It is the parabola. Where's my pen? Right here. There it is. Parent function. Okay. Where would the vertex be? Look at that. It's right there at the origin. Kind of like the parent function of a line. That was supposed to go through the origin. Or the parent function of a absolute value. Those are supposed to be about the same. Or the parent function of a square root function. Or the parent function of a cube root function. Isn't that weird? We've learned all these and they all seem to stem going through there. Well, we're probably going to start shifting and transforming this thing based on where that vertex is. The other thing we're going to base it on is how steep it is, what kind of a dilation we have. Notice here again, as we talk about this, the number in front is a 1. It's understood to be there. What does that mean? We're going to the right 1 and up 1, to the left 1 and up 1. Since this is a quadratic, you're going to hear me say over and over again, we're going up over 2 and up 4, right? That's 2 squared. See, this is 1 squared. Over 2 and up 4, that's negative 2 squared. Then we're going to go over 3 and up 9. Oh, oops, 9 is right here. Lo and behold, that's 3 squared. Or over here, negative 3 squared. You're going to hear me say over and over again, 1, 4, 9. What happens when I put a 2 in front? Well, you're going to hear me say 2, 8, 18. What happens when I put a 3 in front? You're going to hear me say 3, 12, 27. Not when we're graphing it, but maybe, right? All those are multiples of a 149 pattern. The 149 pattern is true for all quadratics. Now, whether or not we have a dilation or a number in front that makes it steeper, that's another thing. What if I put a 1/2 in front? Well, it's going to be 1/2, 2, and 9/2. Oh my God, Mr. Cross, do you mean 4.5? You people and your decimals. All right, in this case, 4.5 probably a little bit more helpful than 9/2 because 9/2 is hard to graph, but 4.5 is not too bad to graph. But I'm still getting aggravated by those decimals. You guys are going to send me over the edge of those decimals this year. All right, let's get rid of all this crap and let's start talking about this puppy. So, the domain. The domain for almost all parabolas, except if we, I could have lost my thing, except if somehow we restrict it, is negative infinity to positive infinity. Because if you extend this off forever and ever and ever, it's going to go ever and ever left. The range in this particular case starts at 0, right here, and it goes up forever and ever. The coordinates of this vertex is 0, 0. The roots of the equation in this particular equation, The roots of this equation are, in this case, just 0. Where does it hit the x-axis? It only hits the x-axis right here at the origin. Is the parabola a function? Well, of course it is. It passes the vertical line test. Which is to say, for each and every input, for each and every output, there exists one input. How's that work? Let's say it passes the vertical line test because it's 4 o'clock and 5 o'clock in the morning, and I haven't finished this delicious cup of Brugger's coffee yet. I don't even know what I'm saying. By the time I finish it, I should be rich because Brugger's is going to be calling. Would one of you send my videos to Brugger's and say, Mr. Krause is the greatest math teacher ever. You ought to send him some money so he can get a new computer and stop whining like a baby. Is the parabola a one-to-one function? Absolutely not. No way is the parabola an absolute value function or a one-to-one function because it fails, of course, the vertical line test repeatedly. Are all parabolas congruent? That means to say they have the exact same shape and size. Heck no, right? We throw a number in front, whether it be a fraction or a number larger than 1, it's going to get steeper or wider. So, no. And are all parabolas similar? That's a difficult question. Do they all have the general same shape? Yes, they all have the same general shape. So, okay, we'll say it's similar. Standard form of a quadratic is y equals ax squared plus bx plus c. Standard or general form of the quadratic is in that form where the leading coefficient, that's the leading coefficient, I'll call it the LC, is here, and that dictates also whether or not your parabola is going to go up or down, or how wide it'll be, and how narrow it'll be. And then this here at the end, is also going to be my y-intercept. Notice at the end up here, no value, right? 0. There's a 0. There's like a plus 0 there, and that's why my y-intercept is 0. All right. Let's talk about circles. Let's talk about circles. There's the unit circle. Why is this called the unit circle? Because the radius is 1 unit. It's not 1 inch. It's not 1 centimeter. It's not 1 meter. It's not 1 mile. It's just 1 unit. It is what it is. It's the unit. The domain of the unit circle is from negative 1 to positive 1. And look at this. The range is from negative 1 to positive 1. Coordinates of the center of the circle. So, like, oh, and by the way, this is the parent function of the unit circle. We call it the unit circle because it's got a radius of 1. But it's also the parent function. Now, this one's going to change and dictate in 2 ways. We're going to move its center, but we're also going to change its radius quite a lot. In this particular case, the center is 0, 0. Radius of the circle, the radius is equal to 1. Is the unit circle a function? No. You can't even ask if it's 1-to-1. You should dude, you shouldn't even be asking me that. It's not a function. Can't be 1-to-1, but we'll say no anyway. Are all circles congruent? No. Are all circles similar? Let's say yes. Why not? Standard form of a circle. All right, so the standard form of a circle is x minus h squared plus y minus k squared equals radius squared, where this is the center. The center is h comma k, and obviously r equals the radius. Slam that on there. And I don't know why I went through all that. I think on the next page I'm actually going to label this thing. And there's something missing in my diagram. I'm going to see if I can print this before you. I just realized I didn't have this in here, so I'm going to do it before I print this in. Okay, that wasn't even English. It sounded like Lou Holtz talking in his last couple of years. By the way, Lou Holtz, we loved you. We loved you. We still love you. But that one video when he goes, that's what I sound like sometimes. All right, let's talk about all this stuff, and then we're going to talk about what's missing. Because that's this like, what's missing? What is missing? All right. So these are called the roots or the zeros. Oftentimes they will be the solutions of a quadratic. Now, remember, all parabolas are quadratics. So it'll be the solution of the quadratic. So when you solve a quadratic, like when I give you x plus, x squared plus, let's make something up, 8x minus plus 12, and you go, oh, that's x plus 2, x plus 6, and you say, oh, the answers are x equals -2 and x equals -6. These are your roots, they're your zeros, or they are the solutions of the quadratic. And when we're looking at it graphically, it will be the x-intercepts, where it passes the x-axis, crosses the x-axis, x-intercepts. And I should not say crosses, I should say intersects, because sometimes it doesn't cross. Sometimes it just bounces right off of it, just hits it once. In the case of our parent function, it only hits it once, which is why there's only one root or zero. This might be a 2-cup of coffee video, because man, I'm tired. All right, so this right here should be obvious. This is the y-intercept. If you're looking at the general equation of the standard form, it's the c value at the end, correct? It's that number at the end. This is called the vertex. It will either be a minimum or a maximum. In this particular case, since it's way down here at the bottom, it's a minimum. If, however, I decided I would go and do that, then it would be a maximum. And of course, you're all saying, oh yeah, that would be when a is negative, or when a is less than 0. Then it's coming down. And this thing I'm missing is this thing that we draw that goes right through the vertex. This very, very straight line. Now, it's not an actual feature of the graph, which is why I think I left it off, but it is a hidden feature that you really, really have to remember is there, but you don't graph it. Okay, and that's called the axis of symmetry. Symmetry. There's Mr. Krause's spelling. Someone tell me if I misspelled that someday. Axis of symmetry. This will help us find the vertex, and we're going to talk about that today. So it's used to find the vertex. It's really important you understand that. I always hammer home that you got to find that that axis of symmetry before you really do anything else. It also tells you that, you'll have equal distance or symmetry going to the left and the right. Those distances, if this is 5, I don't know what it is, then this will be 5. Down here it might be 3 and 3, but it will be equal distance off to the left. Hence the idea of symmetry. Now, before I do anything else, I'm going to find this missing axis of symmetry. So what I'm going to do, now I'm not going to use the official formula. Some of you probably remember the formula. I'll do that later. But because this is graph for me, I really don't have to do that. Oh, by the way, the axis of symmetry is a vertical line. And if you remember correctly, all vertical lines have that formula, x equals something. So that's a vertical line. Remember, horizontal lines are y equals. They go the other way. In this particular case, x is equal to, what is x equal to? 1. So x equals 1 is my axis of symmetry. Well, I'm going to use that fact to come down here and find the vertex. Remember, we use the axis of symmetry to find the vertex. The vertex is always 1, it's always whatever that axis of symmetry is. Whatever you found out here will be your x coordinate of your vertex. The y coordinate then is just the other part. Now in this case you should say, oh, Mr. Krause, why did you just come down here and say it's 1, 4? 1, -4, thank you. 1, -4. Yeah, I know I can read that. But when I just give you this equation, or this function, and I don't give you the graph, then how are you going to find it? What you need to do is then take this 1, actually plug it into this function, and it will pop out a -4. Let me prove that to you. F of 1 is equal to 1 squared minus 2 times 1 minus 3. Well, this becomes 1 minus 2 minus 3, which is in fact -4, which is why that value is what it is. Okay, y-intercept. Y-intercept. I like the y-intercepts given as a point. In this case, it's 0, -3. Remember, it's the c value of your equation. And if I look up here, right there, see, there it is, -3. Can't see it now because I drew over it. That was stupid. See, right there, -3. Let me highlight it right there. Ooh, in green, isn't that festive? Wow, fancy green. All right, so that's the y-intercept. That's the x value. Okay. Now let's go back. We've got these roots or zeros or solutions or x-intercepts. Isn't that weird? It's like got like 8 names. So you'll hear me call it roots most of the time. Sometimes you'll hear me call it zeros, x-intercepts, solutions. You're going to get really tired of talking to me because I'm going to confuse you. And you're going to have to keep all that stuff straight. So the roots, the zeros, the solutions, or the x-intercepts, in this case, are x equals -1 and x equals, what is that, 3? So if you were to factor this thing, you would factor it to x minus 3, x plus 1. Let's see if that makes sense. Our function is x squared minus 2x minus 3. Now, why did I get this? Well, I got this because, remember, wouldn't this tell me my answer here was 3? And wouldn't this tell me my answer here is -1? So when they go back into the parentheses, they go back in with opposite values. Now let's see if this makes sense. Oh, yep, that's -3. And yes, they add up to -2. Kind of cool, isn't it? We're going to talk about that later. Let's move on. Oh, domain and range. We've already said this before. Domain, -infinity to positive infinity. In this particular, the range, again, this is our lowest value. Range will always start or end at the y value of the vertex. In this case, it's going to start at the y value, and it's going to go forever and ever up. And the reason it's going to start at the y value and go up is because it is a minimum. Minimum. I think I spelled that right. If this was a parabola that was upside down, and let's say this vertex was 1, -4, and it was going down. Well, in this case, right, in this particular case, then, this would be the highest point. And remember, when you're dealing with interval notation, the small number goes on the left and the large number goes on the right. So for this particular case over here, I would have to write from -infinity up to -4 and including -4. So that's not the case here, but I just wanted to make sure you understood that if in fact it's a maximum, in this case it's a maximum over here, that the vertex value will be on the right, and if it's a minimum, it will be on the left because it's the smallest value. All right, you're going to try it. So notice I'm going to start here with the axis of symmetry. So again, I've given you the thing. So let's say straight axis of symmetry right down here, the y-axis. And the equation for the y-axis is x is equal to 0. The roots of this equation, I'm just going to do it like this because I got 2 of them, are -1 and +1. The y-intercept, there it is right there, right? 0, 2. The coordinates of the vertex, well, in this case, it happens to be the same as the y-intercept, 0, 2. Domain and range. Well, domain, -infinity to positive infinity. Get used to that. Unless it specifically restricts the domain somewhere back down here, it'll always be negative. The range, though, will be a little bit different. This is what I was talking about before. Because this is now a maximum, my vertex, where is it? My vertex is a maximum. That means this is the highest value. That means we're going to find it on the right side. So on the left side is negative infinity, all the way up to 2 and including 2. Pretty exciting stuff. Oh my God. Mr. Krause, I love math. Psycho. Where are we going? So the equation for the axis of symmetry, and I think you guys probably remember this, is x equals, see why I need a new computer? X equals negative b over 2a. So when we're trying to figure out what the vertex is, the x value will be negative b over 2a, and the y value will be f of negative b over 2a, which is just to say that this is the axis of symmetry, and you plug it in order to find the y value of the axis of symmetry. Let's see what that looks like. We're first going to find the axis of symmetry, and we're going to do it algebraically. We're not going to look at the graph, okay? Are you looking at this going, okay, Krause, seriously, what is this? Why would you do that? Well, I kind of did this so you can't look at it graphically. Y-intercept of 66. But I am going to need my calculator for this one because I forgot I decided to be a jerk on this problem. Yes, I can be a jerk. I know you're all thinking, sitting there going, but Mr. Krause, you're the nicest guy ever. You're so nice and friendly, and you never scare me, and you never throw things at me. Sorry, Mr. Pennell. That was a mistake. Although, Mrs. Coppola, you need some new erasers because it's scary. So let's start working on the axis of symmetry. My axis of symmetry is x equals negative b over 2a. Now remember, this is a, this is b, and this is c. Now, if I don't have an... So a is the x squared term. B is the x term. C is the constant at the end. This is always true. So if I gave you the function f of x is equal to x squared plus 5, is there an x term? No. So what's b? 0. Right? If I gave you x squared plus 5x, is there a c term? There's none. The c term in this case is missing. So in this case, the b would be 5. So just remember that. That's important that you remember that. All right, let's go back to the problem. And I'll erase first. Should have written in cursive, and it would all come out at once. All right. Let's go. I'm tired of red. So, negative 89 over 2 times 14. Which is negative 89 over 24. I'm going to guess that this does not simplify. Just because 8 plus 9 is 17, therefore 3 doesn't go into it, no even value goes into it. I'm going to guess it doesn't simplify. Some of you are like, well, why did you add those up? The divisibility rule for 3 states, if you add up the digits, and that's divisible by 3, the whole thing is divisible by 3. Every time I blow this up, my big fat head gets in the way. So let me not blow it up that much. I wish I could just move it over there. Move it. Maybe I can do that. Ooh, yeah. Just going to go. Get out of my head. Get away from my head. There we go. All right. So what we're going to do is now what we need to do now is, what is this, h? We need to do h of this thing. Negative 89 over 24. So what I'm going to do is, because I like storing things. So negative 89 divided by 24. I'm going to just store this into x, because I don't want to have to type that in 6 times. And then my function is 14x squared. So 14x squared. Now, if you don't have this calculator, well, the 84 stows as well, so you can do this as well. Plus 89x plus 89x plus 66 Well, that really is an obnoxious parabola. And we're going to get some really dumb number, negative 20,597. Negative 20,597 over 288. So clearly this would not have been, you could not have done this graphically because there's no way you'd find the vertex negative 89 over 24, comma, negative 20597 over 288. Whatever. Use your calculator. I mean, come on. We're not going to do that on a test, by the way. I won't do that. I'm just being silly on this one, trying to drive home the point. That's not that difficult. This is as crazy as it gets. Crazy. Crazy for loving me. Oh, okay. So let's get some normal stuff. All right. Let's find the axis of symmetry in the vertex. So, x equals negative 17. By the way, I'm going to hope at one point very soon that you stop doing this. Negative b is just b with a different sign, correct? Because when I write negative b, that really says take b and change its sign. That should be obvious by now. All over 2 times 3. Again, I'm not expecting you to see that. I expect you to probably be able to just go right from here to, oh, it's change b and throw it over double a. 17 over 6. Now we're going to do m of 17 over 6, which is equal to 3 times 17 over 6 squared minus 17 times 17 over 6 plus 10. Again, clearly not an equation, not something I would do graphically. So 17 over 6. So 17 divided by 6, control var x, enter. 3x squared minus 17x plus 10 equals negative 169 over 12. So my vertex is 17 over 10, negative 169 over 12. Now, when I go to ask you to graph a function and all of its important parts, I'm not going to give you one this redunculously stupid. Let's go to here. X equals negative b over 2a. Now, there's a reason I wrote it this time. Do you see the b? Remember, a is the x squared term, b is the x term, and c is the constant. Okay? In this particular case, there is no x term. It's missing. So my b value is 0. Now, I could put a big flying pile of dung out there. It doesn't really matter. This will always equal 0 if your b term is 0. Which is to say then, when I'm graphing a quadratic that does not have a b value, it's really just, pretend like you can't see this. It's really just the parent function, in this case stretched, make it steeper, moved straight down. Therefore, there is no shift left or right. Doesn't that, and that kind of makes sense here, doesn't it? All we did was take the parent function and go down 64 units. But I'll do 2 times 9, which is 18. So it's still 0. Well, the nice thing about 0 is when I plug in 0, I don't need a calculator. Oops. It's kind of like when I calculate when you get everything wrong on a test, you get a 0. It's pretty easy, right? 9 times 0 squared, oops, minus 64 is, guess what? It's negative 64. So my vertex is 0, negative 64. So it's the parent function moved down 64 units. Let's talk about circles. I've already talked about this form. I called this the standard form. I don't know what I was talking about earlier. Maybe the standard form is x squared plus y squared equals radius squared. I don't know. To me, this is the standard form. This is the way you're going to see it almost all the time. When you have x squared plus y squared equals radius squared, it is actually this same thing, but because the vertex, remember, is the origin, it's really x minus 0 squared plus y minus 0 squared equals the radius squared. Well, I don't need to put minus 0. It just is what it is. So, let's graph this puppy. Why would I ask you to graph one? Whose radius is 7. That's just dumb. We're going to go 6. Why would I do 7? 7's really hard to graph. That's dumb. I'm going to change that. I'm going to change this to, let's go with 9. I don't know why I would put 7 there. 7's kind of dumb. So, my center is 1, -3. So let's plot that. 1, 2, 3. There's my center. And my radius is equal to the square root of 9, which is 3. Remember, 3 squared is the radius. Radius squared. So in order to undo that, I have to take the square root. Which is why putting a 7 there would have been dumb. So I apologize. Yep, up 3, left 3, right 3, and down 3. And then I've had that sneeze ready to go for like an hour. I got another one coming. Here it is. Sorry. I think I'm done. I don't know why I'm sneezing. And then there's like 0 chance of me drawing a very good circle here. Because I'm actually really good at this. But not with this pen. Okay, there it is. There's my circle. Wow, that's exciting, Mr. Krause. Okay, over here, the center is 0, 4. Remember, we're going opposite. And the radius is 12. Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm not going to get there. And it's not okay to do this. 12. Not okay. You have to change your scale. And if in order to change the scale on a graph, you have to actually tell me you're changing the scale. So just come down here and say we're going to go 2 by 2. So my center is 0, 4. 0, 4 is actually right here now because every square represents 2 up and 2 down and 2 left and 2 right. So I went 2, 4. Now I'm going to go to the right 6 or 12. 1, 2, 3, 4, 5, 6. Now I should be counting by 2s, right? 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. 1, 2. 1, 2. Lost track down there. And there's like, again, no chance of me drawing this in very nicely. I'm going to be a little bit critical of you, how you draw these. If you draw straight lines in between those points, clearly that's a square, and I will take off points. All right, there we go. So I expect you to state the center, -1, -2, and I expect you to state the radius. It only takes a second. -1, -2, right 2, up 2, left 2, down 2. Now, did I have to put a scale for this one? If the scale is 1, you don't have to put a scale. It's understood to be the 1. Anytime you want to change the scale, yeah, then you got to do it. All right. The center, 5, 6. Radius equals 3. 1, 2, 3, 4, 5. Oh my God. 1, 2. 1, 2, 3, 4, 5, 6. Here it is. Let me get rid of my crap. Yeah, that's what happens when you get old. You can't see anything. It's all blurry. Yes, I wear glasses, but they're actually just reading glasses. My actual vision is very, very good. The problem is that I can't read anything. I am getting old. By the way, I just had my 47th birthday. Yes, I know you're all saying, man, you're 47. I thought you were 147. Thanks. Just because I'm slightly follically challenged doesn't mean I'm old. Okay, I'm 47's old. There we go. Ooh, that wasn't a bad circle. All right, this one is, the center is 0, 7. That's right. Here. And my radius is 1. Up 1, down 1, left, right, 1, up there. little dinky circle. And here my center is the origin, 0, 0. And my radius is 7. I forgot to tell my radius down 1. 7. Doggone it. This one's going to be a pain in the neck. I go left 7, up 7, left 7, down 7. By the way, the reason I can do that is because I'm coming back 3, since I know these grids are all 10 by 10. Oh my God, that is one ugly circle. All right, that's ugly. So, writing the equation of the circle, remember, we're going to do x squared plus, this is something right here. I'm going to actually highlight it. I'm going to highlight it in. I'm going to highlight it in. Let's go yellow. That's often missed by kids. Often missed by kids. Remember, it's x plus and the x center plus y and the y center, both of which squared is equal to the radius squared. So we're not going to need that squared. Well, let's do it. We're not going to need that squared. We're going to do it all. So, and I'll put the black in. So my x center is -1. When it comes in, it is +1 backwards. My 9 goes in as a -9, and my radius goes in squared. So there is my equation: x plus 1 squared plus, often missed, don't forget it, y minus 9 squared equals 144. All right. So this is going to be x minus 0 squared, which is kind of dumb. I think you guys could probably skip that step. Plus y minus 6 goes in backwards is equal to 2 squared. So this is really x squared plus y minus 6 squared equals 4. Write the equation of the circle. So -2, what am I doing? I'm like a monkey, start just writing stuff down. That's redunculous. X plus 2 went in backwards, squared. Don't forget the plus sign, often missed. I don't know if I said that yet. Y minus 3 squared, often missed, squares, just you get lazy, is equal to 100. Uh-oh. Let me get an idea what this thing looks like. Three negative 4. 1, 2, 3. 1, 2, 3, 4. 6, 5. 4, 5, 6. 1, 2, 3, 4, 5. So I don't know this distance. That's a question mark. It's the radius. I don't know this distance. Now, the easy part is, if it's centered at 3, -4, is x minus 3, x I was just like a kid right there. I forgot the plus sign. There it is. See how easy that is to do? I did not do that on purpose. That was just me being dumb. So it's x minus 3 squared plus y plus 4 squared equals. Now, I don't know what the radius is, so I need to use that distance formula. Distance is equal to, we're going to subtract the x's squared. And then we're going to add to that the subtracting of the y's squared. Let's see. I always start with the second point. 3 minus 6. -4 minus 5. So let's see. 3 minus 6 is -3. -3 squared is 9. -4 minus 5 is -9. -9 squared is, was that 81? So the why did I put D? Oh, the distance. Distance. That could be confusing. The distance is the square root of 90. But I don't want the distance. I want the this is also the radius. I might want to put the radius. Radius equals. The radius is equal to the square root of 90. But remember, in the formula goes radius squared. So you got to take this thing and square it. So this is really equal to 90. Because we're just, remember, the square and the square root cancel each other out. So we're going to... All right, I had to change that function because it didn't work right. So here we go again. Here we go. All right, so in this case, we'll come back to domain and range. You know, if I wanted to use my calculator, that wouldn't be too bad. But what we're going to start with this is this vertex. So x equals negative b over 2a. So this is negative 1. Remember, there's a 1 right there. In this case, it's a negative 1 all over 2 times negative 1. So in this case, my vertex is, or my axis of symmetry is positive 1 over negative 2, which is really just negative 1/2. So my axis of symmetry is negative 1/2. Now I want to find my vertex. My vertex is f of negative 1/2. So I'm going to do negative 1/2 squared plus, that's a minus, minus negative 1/2 plus 6. So let me go over to my calculator and we'll do some calculations. And we'll do negative 0.5 stow x. Yes, I can do fractions or decimals that way. That was a little bit easier. And then we're going to do, actually I don't want to do that. Negative 1 divided by 2 stow x. You'll see why. And we're going to do negative. Oh, I did that. Negative x squared minus x. Was it plus 6, I think? Plus 6. 25 over 4. Which is really just 6.25, just for those of you. This is 25 over 4. For graphing purposes, you might need 6.25. All right, so yeah, I'm giving you a kind of a weird one to graph. It's not a big deal. So is the vertex a minimum or a maximum? In this case, because A is negative, it is a maximum. So we're going to go negative 1/2. I'll do this in red so you can see it. Negative 1/2, 6.25. I also know that my y-intercept is 6, so I can put that on there. Now, the x-intercepts are a little bit trickier. I don't know why this is. Am I recording? Yep, okay. The x-intercepts are a little bit trickier. What we're going to do is we're going to factor this puppy, but I don't like factoring when the x is negative. So it's really negative x squared plus x minus 6. We're going to factor this. Negative x plus 3, x minus 2. So my roots are, or my x-intercepts are, negative 3 and positive 2, which means it's going to go through negative, positive 2, and negative 3. So now if I wanted to sketch this thing, oh, I was going to say, there's negative 3. I went out 4. I knew something was wrong. I went out 4. So I'm going to go like this. I'm going to sketch it now. Sorry, I think just going out by 4 really screwed me up. Oh, sorry about that. All right. So let's keep going. So the domain is negative infinity to positive infinity, and the range is from negative infinity up to 25 over 4, or 6.25. I hate decimals. For what values is f of x negative? This stands for negative. So that means when is it below the x-axis? And it's below the x-axis from negative infinity to 3. not including, or negative 3, but not including negative 3, union 2, but not including 2, all the way up to positive infinity. Now, we're not using this one. We changed functions. It's negative x squared minus x plus 6. Where is that greater than 0? That means when is it positive or above the x-axis? And that's from negative 3 to 2. Not including those. It's not the point negative 3, 2. It's the interval from negative 3 to 2. And if you don't like that, go negative 3 less than x less than 2. Either way is okay. Where is it equal to 0? Well, it's equal to 0 at the roots. Okay, I changed this problem too. Had to take a little break there. I changed this problem too. But what we got to do is sketch this thing. Now notice I didn't give you the axes. So what I want you to do is I want you to think about finding the vertex first and then doing the axes. So in order to find the vertex, let me scroll down. Let me write this function down here. It's x squared minus 4x minus 12. Notice my y-intercept is negative 12. That's already off a normal 10 by 10 graph. So I don't want to put my axes right in the middle because this is my y-intercept. So first thing I'm going to do is find my axis of symmetry, which is negative 4 over 2 times 1, which is 4 over 2, which is just 2. Okay. I found my axis of symmetry. Now I'm going to plug that thing in. So I think my function was g. So g of 2 is 2 squared minus 4 times 2 minus 12. So this is 4 minus 8 minus 12, which is negative 16. So my vertex is 2, negative 16. So, where do I want to put my axes? Well, 2 should be in the center, so that means it's going to move to the left a little bit and way up. So let's just move to the left a little bit. We'll put the axes right here. This should be fine. I might want to find my roots too. Let me do that real quick. X minus 6, x plus 2. That's the factoring of this thing. So my roots are x equals 6 and x equals negative 2. So that's okay. This graph will do that. But I want to put my y-axis way up here because I got to get to negative 16 for my vertex. All right. So what do I know? I know my roots are negative 2 and 2, 4, 6. I know my vertex is 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Actually, my y-intercept is negative 12. 13, 14, 15, 16. See, I barely got that up. Now we're going to go 1, 4s, and 9s. 1 to the left, 1 to the right. Now we're going to go 2 and up 4 and up 4. Then we're going to go 9s. 3, 4, 5, 6, 7, 4, 5, 6, 7, 8, 9, and 9. And then the next one is 16s, right? Well, that's already back up to the axis. So there it is. There is my sick parabola. All right, so what's the y-intercept? Well, that's easy. It's 0, negative 12. For what values is g of x greater than 0? Well, it crosses the x-axis at negative 2, and it crosses the x-axis at 6. I'm sorry, this is positive. This is where it's bigger than x-axis. So that would be starting here and going this direction, or starting here and going that direction. It's positive, right? Because parabola goes down like this. So that means it's from negative infinity to negative 2, or from 6 to positive infinity. And for what values of g of x is increasing? Well, down here at the bottom is 0, and increasing is going up. So that's at the vertex, which is 2, all the way to positive infinity, it's increasing. I think this is our last problem. Yay, finally. Okay, let's label this thing. My x-intercepts are B and D. My y-intercept is A, and my vertex is C. Now, I really should find the coordinates at this point. So let me factor this thing. This is x minus 11, x minus 2. So my roots are 2 and 11. So my x-intercepts are really 2 and 11, where B is 2 and D is 11. A is really just 22. So this point is 0, 22. Remember, because A is my y-intercept. And the vertex is, let's see, remember it's halfway between these two. So that's, the difference between these two is 9. Half of that is 4.5. So if I add 4.5, I get to 6.5. And if I subtract 4.5, I get to 6.5. So I know C is 6.5 comma something. Just don't know what it is. So, or I could do my axis symmetry. X equals negative 13 over 2 times 1. Which this is just 13 over 2, which is 6.5. And I go over my calculator. I go calculate. And I go, okay, 13 divided by 2. So x. And I'm going to do x squared minus 13x plus 22 and negative 81 over 4. Negative 81 over 4. And that would be C. And that's the end of the video. I'm going to cut out some things that didn't go so well, and you should have seen a nice product. Subscribe, kids. Maybe donate if you got a little extra cash. Got a good job, and either you're loving my stuff, or if your parents love it, go say, Mom, donate to this guy's channel. He's awesome. Whew. This was a long one. Adios, amigos. Bye.